Hello, everybody, and welcome back again. Today is lesson 9.2 about tree diagrams and combinations. This is the second lesson in our probability unit. So let's get cooking talking about tree diagrams and combinations. So for tree diagrams, it's probably going to be most helpful if I just show you an example. So here's an example down here. Roger Federer. If you play tennis, hopefully you know who Roger Federer is. If you don't play tennis, hopefully you know who Roger Federer is. If you don't know who Roger Federer is, Google him. So Roger Federer, the way that tennis works is you make a first serve. If you make it, you play the point out. If you don't, you serve a second time. If you miss the second serve, you automatically lose the point. So what we're going to do is we're going to take these probabilities that we're given and draw ourselves a tree diagram to figure out how likely it is that Roger Federer wins a point when he's serving. So 63% of the time he makes his first serve. So we're going to start out here and we're going to say, all right, we're going to start the point. So he makes his first serve. He makes it 63% of the time. So right here, I'm going to put 0.63. So what that means is the 63% of the time he makes his first serve. So if he makes it 63% of the time, then 37% of the time he doesn't. So this is our first branch of the tree diagram. So this is showing when he serves, 63% of the time he'll make his first serve, 37% of the time he will miss it. All right. So then from there, we're going to keep looking. It says when he made his first serve, he won 78% of the points. So when he makes the first serve, so now this is going to break down into win and lose. So when he makes his first serve, he wins 78% of the time, which means that he loses 22% of the time. So 0.22. When he misses his first serve and has to serve again, all right, so when he misses his first serve and has to serve again, he only won 57% of the points. And then he loses the rest. So if he wins 57% of the points, he loses 43% of the points. So what this tree diagram can help us with is if we want to randomly pick just one point where Federer serves, what we could do is if I want this specific outcome to occur. So to find the probability of this outcome, what I'm going to do is I'm going to start at the beginning of the tree diagram and say, all right, in order to get here, I'm going to have to go down this branch. And then I'm going to have to go down this branch. So in order to figure out that probability, I would do the first branch 0.63 times the probability of the next branch 0.78. And whatever that answer is, that'll be the probability of this specific outcome. And I could do the same thing for each one of these outcomes. If I want this outcome to happen, so if I want to find the probability that he wins after missing his first serve, then I would have to go down this branch. Then I would have to go down this branch, and that would be 0.37 times 0.57. And what this will do is if I find all these possible outcomes, it'll give me the probability of each specific outcome. So what I'll do is I'll let you guys find the probability of each of these losing points. And then I want you guys to try to answer these two questions down here. So what's the probability that he wins the point when he's serving, just in general, whether it's first or second? And then this one I want you to think about. I want you to answer if he does not win the point, what's probably he made his first serve. So you might have to think about that one a little bit more. But that is an example of a tree diagram. So on the next few pages, there's some examples that I'm going to let you guys try on your own before class. So this one is about YouTube and internet users. So I'll let you try to make yourself a tree diagram for this and answer it. And then this is also another one in class, much more depressing one about animals being put down at shelters. But you know what? Most of them are not put down. So there's the positive in the situation. So, and we're going to do this one in class. So again, you can go ahead and try it if you want to. So that leads us into combinations. So what we just did is we showed a bunch of different possible outcomes. One thing that might be helpful for that is before you even make a tree diagram or really just any situation, knowing how many different possibilities there are. So combinations are identifying the number of possible ways to choose k individuals from a sample size of n. And this little number down here, this should be a k, not an r. So we're going to put a little k right here. Sorry. There we go. So this is how we choose k individuals from population of size n. So this is denoted as NCK. That means n choose k, and can be calculated using this formula right here. So this is n choose k. To do this, I do n factorial over k factorial times n minus k factorial. So this exclamation point is called a factorial. To calculate a factorial, you multiply every positive integer from the value until 1. So for example, 5 factorial is 5 times 4 times 3 times 2 times 1, which is 120. So we're going to do one example of this together, and we're going to say, all right, so I, Mr. Cook, when I make a quiz, let's say that I make a question bank of 5 possible questions you could get for the quiz. So what the quiz is going to do is it's going to randomly select 3 of those 5 questions, and I want to know how many different questions could occur. So to figure this out, I could do 5, choose 3, because there are 5 total possible questions, and the quiz is choosing 3 of them. So the number of different possible combinations I could calculate as 5 factorial over 3 factorial times 5 minus 3 factorial. So this is going to be 5 times 4 times 3 times 2 times 1 over 3 factorial is 3 times 2 times 1 times 5 minus 3 is 2. 2 factorial is 2 times 1. So what ends up happening with these is I notice 3 divided by 3 is 1, 2 divided by 2 is 1. None of the ones are really relevant because multiplying or dividing by 2 doesn't change anything. So what this gives me is 5 times 4 is 20, divided by 2 is 10. There are 10 different possible combinations. So if I have a question bank of 5 possible questions, I'm randomly selecting 3 of those questions, there are 10 different ways that could happen. So this is pretty simple when we have small numbers of things. So 5 possible questions, 3 questions to select, fairly simple. Sometimes though, it's not always going to be that simple. So what I'm going to do is we're going to try and answer that last problem using the calculator. So I want to try and calculate 5, choose 3 using the calculator, because if I give you something larger than 5 and 3, this can become a lot more complicated. So I'm going to show you how to do it. So to do 5, choose 3, you can go to your calculator. All right. You're going to type in the population size. So in this case, 5 is the number of things I'm choosing from. I'm going to type 5 and say, all right, from this 5, I want to choose 3 things. So what I'm going to do is I'm going to press math, go to probability, and number 3, it says NCR. So we're going to do that. And what this is saying is I'm going to take my population of 5. I want to choose. Now I'm going to type 3. So this is 5, choose 3, and press enter, and it gives me 10. The reason this is helpful is, let's just say, for example, let's say that I did 10 possible questions and I wanted to choose 4 of them. You see, I get a much larger number. Let's say that I had done 510 possible combinations or possible questions, and I wanted to choose 25 of them. I get a very, very, very large number. So this gets much, much harder to calculate by hand as these numbers get larger and larger. But that's how I do it in the calculator. So I want you to practice a little bit with your own calculator. And let's say, all right, Mr. Cook is not that simple. He's not that easy. And he's not just going to make 10 different possible combinations. So what I want you to figure out is, if I make a bank of 50 possible questions and I want to select 10 of those questions, how many different possible combinations are there? So bring your answer to class. We'll do it in class and we will see what this looks like. This is actually a lot closer to the way that I make your quizzes and tests and things. So you'll see how many different possible combinations there are. So that is it for today. Today we talked about 2 major things, tree diagrams and combinations. I hope you took some good notes. Come to class with any questions that you have, and I hope you have a wonderful day. I'll see you in the next video.